Okay, I just skimmed Busboy and it's wild. It parses multi-part form data by streaming files, not buffering the whole request up front, which feels almost magical.
Wait, seriously. So it emits file and field events as data arrives, letting us start processing chunks immediately instead of waiting for the end.
Exactly, plus it exposes a parser stream with configurable limits like file size, fields, files, and parts, offering guardrails against wild uploads.
That's helpful, but what about encodings? Def charset is UTF-8 and def param charset Latin 1 could misinterpret data if used blindly in real apps.
Another surprise, preserve path defaults to false to prevent path traversal. You should hash or sanitize file names before saving them.
However, listening for file really demands consuming the stream. Otherwise, finish and close never fire, which is a subtle pitfall developers stumble over.
Yes, and you can save to disk by piping the file stream into FS. Create write stream, turning streaming data into tangible files on disk.
Security note: enabling preserve path or using raw file names can leak local paths. Sanitize or hash file names for safety.
There's a robust limits object. Field name size, field size, files, file size, parts, header pairs, each with a sensible default to curb abuse.
Those limits are powerful but brittle. Push too hard and you block legitimate uploads. Balance usability, performance, and protection.
Crucial content type boundary must be present for multi-part. Missing it can cause busboy to throw or misparse, so validation matters.
Docs mention finish and limit events. If a file hits file size, the stream flags truncated and emits a limit event for visibility.
In examples, saving to disk uses a TMP dir with busboy upload random name, a practical approach for organizing uploads.
That random helper uses cryptorandom fillsync to generate hex strings. Collisions are unlikely, but worth handling in orchestration.
API design treats busboy as a writable form parser stream. You wire event handlers and respond once parsing completes.
Also, backpressure matters. High watermark controls how aggressively we pull data. Tuning is not always obvious at first glance.
Field events return value, and name truncated value truncated flags help detect oversized fields without guessing their fate.
Note, you should never trust file name as is. Hash or generate safe names before saving, especially if preserve path is off.
Limits also expose parts limit, files limit, fields limit signals when quotas are reached, so you can throttle or fail gracefully.
With many parts, you'll hit parts limits. Plan to parse progressively or drop non-essential fields to stay within safe bounds.
Node version guidance matters. V1016 Plus for busboy, but with Node 18 Plus, the request timeout default can interrupt long uploads.
That could bite real apps. You'd need to adjust request timeout or configure the server to tolerate longer uploads.
Again, preserve path default false is a security best practice. Turning it on requires extra sanitization to avoid leaking sensibles.
Even so, hashing the file name before saving helps local safety and makes audits easier during incident response.
The simple example uses file field and text field. It shows how file and field events mix when you handle a form.
Error handling matters. If content type isn't multi-part or the boundary is missing, busboy will throw. Plan for try-catch.
Config fields like high watermark and file HWM tune memory and throughput. You'll adjust for small or large uploads depending on load.
Edge case, multiple files, many fields. Ensure you consume every file stream. Otherwise, finish won't fire and the server stalls.
MIME type shown by info MIME type helps routing decisions, but you shouldn't trust it blindly for security or storage choices.
Yes, these pieces form a toolbox for building robust upload handlers. Later, you can pipe the data onward to storage.
I wonder about memory versus disk usage. Busboy streams avoid buffering, but some apps still buffer metadata. Every choice has trade-offs.
Limiting fields is wise for DOS protection. Infinity defaults might surprise new users. Set sane caps tailored to your app.
Another caveat, the file name value is not safe to trust. Generate a safe name or hash before saving to prevent surprises.
Nice touch in logs. File name. Done and done parsing forms show you're getting end-to-end visibility and debugging clarity.
On termination, rec, pipe BB and BBON close to respond. It's a clean, eventful finish rather than a silent drop.
Consider a huge file with tiny memory footprint. Streaming handles it well, but you should monitor timeouts and back pressure.
Distributing uploads beyond disk, you could pipe to cloud storage. Streams let you scale without rewriting logic.
One downside, busboy doesn't transcode. It hands you raw data. Handle encoding externally if you need consistent text.
Def param charset affects multi-part header parameters, not just values. Watch misinterpretation of file names and content dispositions.
Field name size limit matters. A pathological field name could exhaust parsing. Limits protect against such abuse.
Event-driven by design, you can branch logic on MIME type or use a custom transformer per file to fit your flow.
Security lens. Verify MIME type on receipt. Don't rely solely on content type. Headers can be spoofed in practice.
In the big picture, Busboy embodies Node's streaming ethos, process big uploads without blocking the event loop.
True, yet over-engineering can creep in. Some apps don't need all these controls. Start lean, then add rigor.
Breaking changes note in V100 means migration pitfalls. Read issues and changelogs before upgrading in production.
Bottom line, busboy gives back pressure, safety nets, and precise parsing. It's a powerful building block for uploads.
Takeaway, plan path sanitization, sane limits, and test against edge cases to keep uploads fast, safe, and auditable.
Test scenarios including huge files, many fields, odd characters. Ensure finish fires and there are no silent stalls.
Core insight, streaming, events, and configurable limits let you build scalable, resilient upload handlers for real apps.
Final ponder. As runtimes evolve, can we simplify config without sacrificing safety, performance, or auditability?